can write only the pattern of t equals to 1. So this is basically, you don't need, you can follow from the convolutional code that we have. I've told you that the relation between the error correction capability and the d minimum. So Hamming distance equals to 3. So what was the relation? The relation was like the error correction capability. If there is an error of 1, so the relation between that number of error and the d minimum, that means Hamming distance, equals to 3 minus 1 by 2. That means d minimum minus 1 divided by 2 equals to t. So here in the previous para, there was a single error. So if t equals to 1, so this will be what? 3 minus 1 by 2. So this is another case. We don't have to consider it. But the thing is that here, when we are concerned about calculating the two errors, we need 4 equations, but we have only 3 roots: alpha, alpha square, and alpha to the power 4, right? So that is why here it is written that the other elements of the extended field GF8, other elements of the extended field GF8, which is alpha cube, alpha 5, alpha 6, which were found not to be the root of the generator polynomial G1x of the Hamming code 7,4, can however be the root of the another polynomial, and thus that means here we have considered the generator polynomial as 1 plus x cube, but considering GF8, another possible polynomial was what? X cube plus x square plus 1, and the roots of that polynomial are x alpha to the power cube, alpha 5, alpha 6. Okay, and let me just erase it. Okay, so these are the factors. These are the roots of this equation, which is also a possible polynomial of GF8, because we have already seen from this PDF. These are the possible polynomial of m equals to 3. Also, we have seen from this table that these are the possible polynomials when m equals to 3. Okay. Now, the thing is that this polynomial also generates a linear cyclic code 7,4, because this polynomial is a factor of 7x to the power 7 plus 1. We have already known to this. Okay, so in chapter 3, because this polynomial is a factor of x to the power 7 plus 1, and in fact both polynomial, that is g1x and g2x, are factors of x to the power 7 plus 1, right? So this is known to me that x cube plus x square plus 1 is a factor whose roots are basically alpha cube, alpha 5, and alpha 6. And again, the another possible polynomial was, which was g1x 1 plus x cube, whose roots are basically alpha, alpha square, and alpha to the power 4, right? But in case of determining two error in the received code, so we need minimum 4 equation, but we have only 3 equation, considering the roots alpha alpha and alpha square and alpha to the power 4. Okay, we need another one. So here it is written that this is g2x, okay, and this was the g1x. So g1x and g2x, these two are both the factor of x to the power 7 plus 1. Okay, so in In fact, both polynomials g1x and g2x are the factors of this, and the remaining polynomial that gives the whole factorization, remaining polynomials that gives the whole factorization, what was that? G3x equals to x plus 1, whose unique root is element 1 and the extended field. Okay, in this way, all the non-zero element of the extended field are the roots of x to the power 7 plus 1. This is basically written same concept like x plus 1, the roots is 0 when I'm considering x, so the root is 0. And when I'm considering x plus 1, the root is 1, and these are the corresponding roots. Okay, so and these are the possible polynomials. Okay, now the thing is that this is very important, that the polynomial g1x means 1 plus x cube, right, is called the minimal polynomial of the element alpha square and alpha to the power 4. That means the roots of the corresponding possible polynomial is called the minimal polynomial. This polynomial, okay, 1 plus g1x means 1 plus x cube, is called the minimal polynomial of the element means its root alpha square and alpha to the power 4, right? Same as g2x equals to alpha 2x is called the minimal polynomial of the element alpha cube, alpha to the power 5 and alpha to the power 6, which are the roots of g2x. g2x is 1 plus x square plus x cube, right? And g3x is the minimal polynomial of the element 1. We have already seen from this handwritten note that when I'm considering this degree of 3, x cube, and x cube is replaced by 1 plus x and the root was 1, right? When x cube plus x square plus 1, then the root is cube 5, 6. When cube plus x plus 1, then the root is alpha square 4, right? And this is 0. That means from this table we can say these are the minimal polynomial. These are the minimal polynomial of GF 2 to the power 3, and the elements are alpha cube, alpha to the power 5, alpha to the power 6, and these are the minimal polynomial. These are the minimal polynomial, and the elements of this minimal polynomial are alpha square and alpha to the power 4. This 1 plus x is the minimal polynomial of GF 2 to the power 3, and the element is 1. So element means it's a root. And again, for x cube plus 1, this is x, right? And the root is 0. So this is another minimal polynomial of element 0. So this is basically written here. So here in that book, this 1 plus x is considered as g3x. This a 1 plus x cube is considered as g1x. And 1 plus x square plus x3, this is considered as g2x. Okay, here. So this is written here. Okay, so now the thing is that we come to our problem, that what was our problem, that we have 2 error in our receive bit, but and we need to generate 4 equation, but we have only 3 roots. to make 3 equation, but we need one another root